Today we are going to be solving equations. So we are solving, which means we're finding the answer. Okay. And remember, an equation is a number sentence with an equal sign. Okay. So that means we're going to have an equation and we are going to solve for the variable. So a couple things I want to kind of talk with you about. These are things that you probably already know, but you need a reminder before we go into this lesson. So for instance, what does the equal sign mean? And the reason I'm bringing that up is because a lot of times when I talk to fifth graders about this, they tell me in essence that the equal sign means you have to find an answer. I know that in the past you have had a lot of worksheets where that is true. You know, they give you a problem to do and they say equal and then there's a blank line and you have to find the answer. However, that's not really what the equal sign means. Okay, the equal sign means that everything on one side of the equal sign is equal to the other side. And how I think about that is a balance scale here, is what that's called, a scale balance. Okay, um, if I have something on this side and something on this side, I want them to be equal. Okay, so for instance, over here, 8 times 9. If I have 8 times 9 on this side and 72 on this side, they're equal. Same with this. 1 plus 1 on one side, 2 on the other side, they're equal. Now, another thing that a lot of fifth graders have told me in the past is that a equation should only look like this. Okay, with the what you need to do on one side and the answer on the other. Well, that's not true either. So if I look here, both of these kind of look a little weird because we're not used to seeing that. We're used to seeing 40 plus 7 equals 47 instead of the 47 on one side. Same thing here for the 28. But it goes back to what that equal sign really means. The equal sign doesn't mean find an answer. The equal sign means everything on this side is equal to what's on this side. And the reason why that's so important when we're solving equations is because you need to remember that everything on one side is the equal value of what's on the other side. The other thing that you need to remember is what an inverse operation is. So I took this definition straight from your math textbook. So they say that an inverse operation are operations that undo each other. For example, adding 6 and subtracting 6 are inverse operations. You guys already know this because in younger grades, when you were learning how to add, subtract, multiply, and divide, you know that you can do the opposite operation to check to see if you did that correctly. So for instance, addition and subtraction are inverse operations. So if you do an addition problem, 28 plus 37, and you get an answer to that, you know that you can use subtraction to check and see if your addition is correct. Same thing if you have a subtraction problem. If I do 28 minus 17, and then I get an answer and I add that back to 17, then I'm checking my subtraction problem with addition. And the same thing with multiplication and division. And we did this a lot when we were working on our division. When we would get our quotient, we would always go back and check with multiplication to see if we got that correct answer. Okay, so you have to know what an inverse operation is to help you with solving equations. So now, what does that look like? All right, so I'm going to start with something super simple. And I'm not even going to use a variable right now. So if I have this equation, square plus 3 equals 10. When I say I want you to solve that, what I want you to do is I want you to find what goes in the square. Now, most of you can probably tell me 7 without really having to think about it. Okay? You just know your facts. You know that 7 plus 3 is 10. That's super simple. Let's pretend you didn't know. that that was 7. Okay? What you're going to do is you're going to use your inverse, okay, whoops, or opposite operation, okay? What's the opposite of addition? That would be subtraction, okay? So if I do subtract 3 on this side, what that's doing is it's taking this 3 away, and I'm left with just a square. And whatever I do to one side, I do to the other side to make it balanced. Okay, so 10 minus 3 is 7. Okay, so I'm saying that the square is equal to 7. And I can check that if I take the 7 and I plug it back into the square. Is 7 plus 3 10? It is, so I solved that correctly. Okay, so think of a balance. This is my weird balance, okay? So on this side, I have the square and I have the 3. On this side, I have 10. Okay? So what I want over here is I want this square all by itself. I don't want these 3 things here because I'm solving for the square. So in order to get rid of these 3, I'm taking them away, right? Okay, taking them away, so I'll erase those 3. Now, if I take away 3 from this side, I have to take away 3 from this side too. 1, 2, 3. And what I'm left with is 1, 2, 3, 4, 5, 6, 7. So I'm saying square equals 7. Okay? Now, we're going to do the same thing, only we're not using squares. We're using variables. So let's do this again. Let me clear this. Okay? Let's say that this time I have 3x equals 18. Okay? 3x equals 18. Remember, 3x means 3 times x, right? Okay, so if I'm over here and I have my scale, which I know kind of doesn't look like a scale, but it's the closest thing I have. Okay, so here's my equal. So on this side, I have 1, 2, 3x. Okay, on this side, that's not very big. Let me make it a little bigger, just so that you can all fit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, right now they're equal. All right, 3x equals 18. That's balanced. What I want is I want this x by itself. Okay, so what I want to do is I want to get rid of these 3. However, this is not like the last problem. The last problem, I could get rid of it using subtraction because the original operation was addition. Right here, my original operation is multiplication. Okay, so what is the opposite of multiplication? That would be division. So if I say I'm going to divide by 3, okay, what that's really doing is I'm getting rid of these 3. Okay, I divided it by 3. So now up here, I'm left with x on this side. But what I do to one side, I have to do to the other. So now I have to divide 18 by 3. Well, if I do that, I can see that then I have 6 in a group because 18 divided by 3 is 6. Okay, so x equals 6. I want to rewrite that up here so you can kind of see what that looks like again. Okay, so I'm looking for the opposite operation. Well, the opposite operation of multiplication is division. So if I divide by 3, that means I'm getting rid of this and I'm left with just x. What I do to one side, I must do to the other side to keep it balanced. Okay, 18 divided by 3 is 6. So I would say x equals 6. Now I can always check that by going and plugging in the 6 in place of x. Well, is 3 times 6 18? It absolutely is. Okay, so let's do a couple more. Let me just clear this. So I want to do 2000 equals n plus 500. Okay, so if I'm doing my scale, that means I have 2000 on this side. I have n plus 500 on this side. So right now, they're equal. What I want is to get rid of this 500 so that the n is all by itself. Okay, so that's where the opposite operation comes in. So what is the opposite of addition? That is correct, subtraction. Okay, so if I subtract 500 here, okay, I'm left with just n. But if I do it over here, I have to also do it over here. So 2000 minus 500 is 1500. So now I'm left with n equals 1500. This is what that looks like. So I'm going to subtract because that's the opposite. Subtracting 500. Okay, because then what that does is that takes this away and I'm only left with n on this side. But whatever I did here, I have to also do here. So 2000 minus 500 is 1500. All right, let's do another one. X minus 2 equals 18. Make my scale a little bit bigger over on that side. Maybe that'll help. Okay. X minus 2 is equal to 18. Okay, so again, I only want the x on this side. So if I only want the x, I've got to get rid of this minus 2. Okay, in order to get rid of it, I do the opposite operation. So minus 2 would actually be plus 2 to get rid of it, right? So now I'm left with x. Well, if I did it over here, I have to do it here. So plus 2 gives me 20. So that's what this looks like. So plus 2 on both sides gets rid of this, and I'm only left with x. 18 plus 2 is 20. So x equals 20. And I can check that by putting 20 in place of the x. So is 20 minus 2 18? Yes, it is. All right, let's do another one. 14,000 is equal to 2,000 times y. 14,000. 2,000 times y. Okay, so right now they're equal. What I want is to have y all by itself. Okay, so in order to do that, I need to get rid of this 2,000. Well, here's the operation. What is the opposite of multiplication? That is correct. The opposite is division. So if I divide by 2,000, y is all by itself. But if I do it on one side, I have to also do it on the other. So that means I want to divide by 2,000 over here. Well, remember what we talked about with the zeros. If I have zeros on both sides in the dividend and the divisor, I can match them up and get rid of them. So the dividend has 3 zeros and the divisor has 3 zeros. So I can actually match up all 3 on both sides and get rid of them. So now I'm left with 14 divided by 2. Well, I know 14 divided by 2 is 7. So the only thing left over here is y and 7 on this side. Okay, so again, let me show you what that looks like over here. So the opposite of multiplication is division, and I'm taking away 2,000. Okay, remember this is a multiplication sign. So now I'm left with y. If I do it on this side, I must do it on this side. And I'm going to get rid of some zeros because I can match them up and get rid of them. And 14 divided by 2 is 7. And again, I can check that out by checking, is 2,000 times 7 14,000? Yes, it is, because 7 times 2 is 14, and there's 1, 2, 3 zeros afterwards. All right, last one on this video. R minus 200 equals 500. So do my balance down here. So R minus 200 equals 500. All right, so right now they're equal. Over here, I want to get the R by itself. In order to do that, I do the opposite operation. So what's the opposite of subtraction? Addition. So if I add 200, I'm left with just R on this side. If I do it to this side, I have to also do it over here. So plus 200 gives me 700. So R is equal to 700. Okay, now this whole thing that I'm doing over here with the balance is just to illustrate to you that it has to stay equal. Okay, you don't have to draw this balance out, that's not necessary. But I'm just showing you that everything on each side of the equal sign has to stay equal. Okay, one side or the other cannot be bigger than the other. So let's illustrate what we did here up here. So the opposite of subtraction is addition. So if I do this, now the 200 is gone and I'm left with R. What I do here, I have to do here. So plus 200. So R is 700. Okay, and again, always check. So place what the value is that you found in place of the R up here and make sure that it makes sense. Okay, is 700 minus 200 500? Absolutely, then that means that you got that correct.